Today we are starting with Module 2, the first lesson of Module 2, which is why today is Lesson 2.1. You've already written down your learning goal in your notebook along with today's date, October 5th, 2016. Let's get started by turning to the page where you wrote down the learning goal. Now our learning goal today is pretty long, so let's unpack it. Just like we unwrapped the gift I gave you on Monday, let's talk about what this learning goal means. It says your learning goal today is to multiply whole numbers and multiples of 10. So you're going to do a whole number times a number that's a multiple of 10. Using what you know about place value. Do you guys know a lot about place value? Yeah. Using what you know about the distributive property. Give me a thumbs up if you've learned about the distributive property before. You should have in 4th grade. Great. And also the associative property. Give me a thumbs up if that sounds familiar. Okay, now give me a thumbs up if these properties sound familiar, but it's been a long time, so you kind of forget what they are. Okay, so that's why we're going to talk about what they are today and how they relate to whole numbers multiplied by multiples of 10. Okay, 3 different properties that apply to multiplication and division that we've learned in 3rd grade and in 4th grade. And today we're going to do a quick review. My examples, I wrote all multiplication problems, and I want you to do that too. Even though these apply to addition and multiplication, we're working with multiplication right now. The first property is called the associative property. Everyone say that. Associative property. Okay, the word associative kind of looks like the word associate, right? When you associate with someone, you're kind of in a group with them. Or the PTA is the Parent-Teacher Association. That's a group that's made out of teachers and parents. So the word associate tells you that it has to do with a group. Okay? So the associative property says that it doesn't matter in multiplication and addition how you group the numbers. Here we've grouped the 2 and the 4 together in the parentheses. And over here we've grouped the 3 and the 2 together in the parentheses. It doesn't matter how you group them, the answer will be the same. The next property is called the commutative property. Everyone say commutative property. Commutative. Okay, the word commutative sounds like the word commute, right? And when you commute to work or when you commute to school, it means you're going somewhere. So to commute means to go somewhere. And that will help us remember that the commutative property means it doesn't matter what order you put your factors in. As long as you have the same factors, does the order matter? No. Look, I can move the 3. The 3 can commute all the way to after the 2. And they can switch spots. And will the product still be the same? Yes. So the commutative property tells us that the factors can commute from one position to the next without affecting the product. Finally, we have the distributive property. The word, everyone say distributive property. Distributive property. Okay. The word distributive sounds like the word distribute. If I distribute papers to all of you, am I giving you all some papers? Yeah, I'm passing them out. So when you distribute something and using the distributive property, it means that you have to distribute this 3. I'm going to multiply the 3 to the 2 and to the 4. So 3 times the sum of 2 plus 4 is the same as the sum of 3 times 2 plus the sum of 3 times 4. What differences do you notice between the distributive property and the other 2 properties? There's one big difference. Aditya?
The difference is the commutative property and the associative property are all about the order, the group.
Sure.
The distributive property are basically like breaking up the factors.
You got it. Okay, so associative and commutative property are all about the order of the factors, but the distributive property is kind of like you're breaking up the factors and multiplying them separately. You'll also notice that the associative property deals with all, what? Multiplication, right? There's only multiplication signs. The commutative property only has multiplication signs. But does the distributive property only have multiplication signs? It has a multiplication sign and an addition sign, so be careful. The reason for that is because in order to break something up, we have to split it up into 2 parts, and so we have to add them together. Okay? Now, if we have a problem like 4 times 30, that's the same thing as 4 times 3 tens, right? Is 30 the same thing as 3 tens? Okay, then what I can do is I can say, okay, if I have 4 copies of 3 tens, how many tens do I have altogether? Oh, I have 12 tens. And I know that the standard form for 12 tens is 120. So I know that 4 times 30 is 120. Okay. Moving right along, if I have 40 times 30, that's the same thing as 4 tens times 3 tens, right?
Yes.
So if I write that out, that's 4 times 10 times 3 times 10. Yes?
Yes.
Now I'm going to regroup these factors. I have a 4, a 10, a 3, and a 10. I'm going to put the 4 and 3 next to each other in this group. I'm going to do 4 times 3, and then I'm going to do times 10 times 10. Can I do that? What property allows me to change the grouping or which factors are associated with each other? Ella? Yeah, so because I'm using the associative property, it allows me to put the 4 and the 3 in one group and then the 10 and the 10 together in one group. Why might I want to do that? Well, it makes it easier because then I can use what I know about math facts to multiply. What's 4 times 3? 12. What's 10 times 10?
100.
So 4 times 10 times 3 times 10 is the same thing as 12 times 100, right?
Mm-hmm.
Now do we know what 12 times 100 is?
Yes.
What is it?
1,200.
Yeah, so therefore, 40 times 30 is 1,200. Let's try this next one. I have 40 times 300, okay? So I can say that 40 is the same as 4 tens. And 300 is the same as how many tens?
30 tens.
30 tens. Okay. Now, let's break that down even further. So I have 4 tens. 4 tens is the same as 4 times what? Yeah, 4 times 10. And then 30 tens is the same as 30 times 10, right? Can I break that down even further? Sure. 4 times 10 times 3 times 10, because that's 30, and then times 10, right? Now, I want to put the 4 and the 3 together, and then the 10 times 10 times 10 together. What property allows me to group numbers differently, group the factors differently? Arhan?
That's the associative.
Yeah, so one more time I can use this associative property to say that this is the same thing as 4 times 3 times, how many tens do I have? 10 times 10 times 10. Now I can use what I know about powers of 10 and math facts to solve this problem. 4 times 3 is what? 12. 10 times 10 times 10 is? 1,000. So if I have 12 times 1,000, what's my final answer? 12,000. So therefore, 40 times 300 equals 12,000. I know some of you are starting to notice some patterns. Hold on to them, okay? Great. Is there anything we can do to make this easier to solve? Sonia? So you're going to do 400 times 8 plus 50 times 8 plus 1 times 8, huh? What property did Sonia use to be able to do that? What property is that? Talk about it with your table group. Okay, what property did Sonia use? She said, I can do 400 times 8, and then 50 times 8, and then 1 times 8. Is that going to be the same thing as 451 times 8?
Yes.
What property did she use to break apart the factor 451 like that? What property did she use? Lauren? Distributive property. Now she can think, okay, 400 times 8 is the same thing as 4 times 10 times 10 times 8, right? Now, can I use the commutative property to change the order and the associative property to group things differently? I sure can. Let's take a look. What factors do I want to put right next to each other? Do I want it to be 4 times 10 times 10 times 8? Which ones do I want next to each other? Arun?
4 and
I want the 4 and 8 to be next to each other. Can I switch the order? Can I commute the 8 over here?
yes.
Using what property? Great. So I can write 4 times 8 times 10 times 10. I've commuted the factors so that they're in different places. Can I associate some numbers with each other using parentheses? What property allows me to put these parentheses like that, associating those numbers with each other? Associative property, cool. So first I use the distributive property to distribute the 8 to only the 400 part. Then I use the commutative property to commute the factors, so the ones I wanted to be next to each other would be next to each other. Then I use the associative property to put the parentheses and associate those factors with each other. Now I can use math facts. 4 times 8 is 32. 10 times 10 is? So 32 times 100 is? 3,200. Is that my final answer? No, because it's only the answer to this first part. Now I need to do the second part, 50 times 8. What factors? I can break that down to 5 tens, so 5 times 10 times 8. Do I want different factors to be next to each other?
Yes.
What do you guys think?
Yes.
Which factors do I want to be next to each other?
5 times 8.
Yeah, so I can commute that guy over here, can't I? So 5 times 8 times 10. And then I can use the associative property to do that part first. So what's 5 times 8? 40. 40 times 10 is 400. Okay, finally I have 1 times 8. Can I just do that in my head?
Yes.
That's 8, right? So now all I need to do is add up these parts. 3,200 plus 400 plus 8. And that will get me my final answer to find out what 451 times 8 is. So go ahead and add that up and tell me what my final answer should be. Junbok? 3,608. Okay, so by using the distributive property, I can find that my final answer, my final product, is 3,608. Now let's see if we can use that information to solve these next problems. What's the difference between this problem, 451 times 80, compared to this one, 451 times 8? What part is different, Vasisht?
One is using the associative property, and the other one is.
What's the difference between these factors here and these factors here?
Oh yeah, for the first one, 451 times 8, that has no 0. But 451 times 80, that 80 has a 0.
Huh. The fact that there's an extra 0 here means that this product has an extra factor of what? 10, right? Because 80 is 10 times bigger than 8. So that means my product needs to be how many times bigger than the first product? 10. So if I do 3,608 times 10, what would be my answer? 36,080. Okay. Now let's take a look at the next problem. 4,510 times 8. 80. What's the difference? Here's an extra 0 compared to the problem right above it, right? Every time you have an extra 0, that means you're adding an extra factor of how much? 10. Are you adding an extra factor of 10 or of 0? 10. So that means that this product, the answer to this multiplication problem, is going to be 10 times bigger than the answer to this one. So I can do 36,080 times 10. And what would the answer be? Tara? 36,000. Yeah, the answer would be 360,800. Good. Okay. Jack says he has a trick. Let's listen to him. Ella asked such a great question. She said, how come sometimes when we add zeros to the end of the number, it doesn't change the value, but then sometimes it does? If I add a 0 here, does it change the value? No. If I add a 0 here, does it change the value? Yes. It changes it by how much in this second example? 10. Like I added 10? It gets 10 times what? Bigger. What's the magic mark that's making it so that this 0 means nothing, but this 0 makes that number 10 times bigger? Ella? The decimal point. Okay, so be careful. That's a great question.